When we're evaluating functions, we often use a new type of notation called function notation. And instead of having something like y equals 7x minus 3, we'll replace y with something that looks like this. Y, and this is pronounced f of x, y and f of x are exactly the same thing. They're both talking about the output, or what happens when you choose a value for x and plug it into that function machine or plug it in for the variable. The reason that we use this function notation instead of y is because it allows us a very clear way of seeing what value we're plugging in for x. Let's say that we wanted to let x equal 2. Then in function notation, we would simply write f of 2 equals 7x minus 3. Since I know this is function notation and this means f of x, I know that they want x to equal 2. So then I can just plug 2 in for x. So I would have f of 2 equals 7 times 2 minus 3. So f of 2 in this case, 7 times 2 is 14, and 14 minus 3 is 11. So f of 2 has a value of 11. Very easy way to see what's happening. So I don't even have to have this statement anymore. I can simply go from f of x to f of 2. So let's take a look at a couple examples. So let's say that I was looking for f of x equals 4x plus 4, and I was told to find f of 3. So I would simply plug 3 in for x everywhere that x shows up. So f of 3 is 4 times 3, which is 12, plus 4. 12 plus 4 is 16. So for the statement f of x equals 4x plus 4, when I found f of 3 has a worth of 16. Let's do another example. On this one, instead of f of x, let's change things up. It's still function notation, but we're not stuck with those variables. On this one, let's do f of n. Let's say that f of n is 4n minus 7. And we are asked to find f of negative 1. So we have f of n, and everywhere I have an n currently, I'm going to plug in a negative 1. So f of negative 1 is 4 times a negative 1, which is negative 4. Bring down the minus 7, making f of 1 negative 4 minus 7, or negative 11. All right, one last example. This time, let's say that we're dealing with p of x, and p of x is 2x plus 5, and we are asked to find p of 1/2. So everywhere we see an x, we're going to replace that with 1/2. So p of 1/2, oops, sorry, get that to be an equal sign, equals 2 times 1/2, which is 1. Bring down the positive 5. 1 plus 5 is 6. So p of 1/2 has a value of 6. So you can see different examples of function notation, but it's just kind of an easy way to see what's happening rather than use y.